Hey guys, let's discuss new problem from graph, which is called find the shortest path in a unit weight graph. Okay, so you would be given one graph whose every age weight is unit, means 1. Okay, so you need to find the shortest path between the nodes. So you would be given this age relationships, right? So like let's create a graph from this. So first 0 is coming here. Okay, 0 is connected to 1. Okay, 0 is connected to 3. Fine. Then 1 is connected to 2. Okay, now 3 is connected to 4. Okay, now 4 is connected to 5. Okay, 5 is connected to 6. Okay, and then 2 is connected to 6, like this. And you have the unit weight. Okay, so now you need to find the shortest distance. See, we will use BFS here. Yeah, we will use BFS here. Okay, because this is undirected graph. And so let's check. Okay, so what we do in BFS, nothing. See, first you have created the adjacency list. Okay, and then after that you will create one queue. Okay, and here we will create one distance array as well, because we need to find the shortest path, right? So add all the vertices here. Okay, 0 1 2 3 4 5 6, and initially the distance for all the vertices is infinite, maximum. Okay, let's say, and for 0 it is 0. Fine, because this is our starting node. So now when you start from 0, add that into the queue. Okay, now check all its adjacent nodes, so 1 and 3. So what you will do, you will add, so first you remove the element from queue. Okay, and then add its adjacent elements of 1 and 3. Okay, now you will pop element from queue again, first in first out. So you will first pop 1. Okay, and for 1, see, for 1 means from 0 to 1. Okay, so what will be the distance from 0 to 1? 0 to 1 will be 1, right? Here this is 1 only. So what is current distance? It is infinite, so you need a shortest path, right? So shortest distance, so this one will become 1. Okay, now after 1 it's time for 3. So you just pull this element 3 from queue. Okay, and let's check what is the distance for this 3 from 0. So it will be 0 to 3, it is 1. Okay, so it will be 0 to 3, so 1, and currently it is infinite, so you will put that 1 here. But before, when you poll the element 1, right, so its adjacent is 2, so you have added that 2 into the queue. Now it's time for 3, so 3's adjacent is 4, you have added 4 into the queue. Okay, now it's time for 2. So what is the distance for 2 from 0? So means we can say 1 to 2, right, because it is the adjacent was 1, right? So 1 to 2. So whatever distance we have till 1 plus 1. Okay, so till 1 we have 1, and this one is 1, so 2, right? So for 2 it is currently it is infinite, so 2 is lesser, so okay, I can take 2. Fine. Now it's time. Now what is the neighbor of 2? It is 6, so I have added 6 into the queue. Now it's time for 4, so I will poll the element 4. Okay, and so 4 was adjacent of 3, right? So what is the distance of 4? So means till 3 to 4. So till 3, what was the distance? 1. And what will be for 4? So 1 plus 1, 2, right? Currently it is infinite, so okay, I can add 2 here. Now it's time. What is the adjacent of 4? It is 5, so you have added 5 here in the queue. Okay, now it's time for 6. So what will be distance for 6? Okay, it came from 2. So whatever distance we have till 2 plus 1. So till 2 we have 2, and then plus 1 means 3. Currently it is infinite, so okay, 3 is lesser, I can add 3. Now it's time for 5. So I'll poll the value 5. Okay, and what is the distance here for 5? So whatever distance of its adjacent, see, till 4 it is 2, till 6 it is 3. So I'll definitely take 4 path, okay, route. So from 4 and plus 1, so 2 plus 1, 3. So this one will be 3. So this one will be your path. See, for 0 it is 0. Okay, for 1 it is 1. Fine. For 3 it is 1. For 3 it is 1. Okay, for 2 it is 2. 2 it is 2. Yes. For 4 it is 2. Okay, correct. 5 it is 3. 5 it is 3. Yes. And 6 it is 3. 6 it is 3. Correct. So this is how you will find the path. Means it is see, 0 is connected to 0. Okay, then 0 is connected to 1. Okay, then 1 connected to means something like that. 0, say 0, 1 to 1, then 3 to 1, means this is the distance. Okay, from 0 to 0, then 1 to 1, then 3 to 1, so 3 to 1. Yeah, no, that is the distance actually for each node. Okay, now let's check what is happening in the code. Whatever we did, that is only happening in the code, right? So what is given? The n. Okay, and then 2D array ages, and then source node is 0, for example. So now first you will create an adjacency list. Okay, so from 0 to n you will create an array list of array list. Okay, and then inside that array list you will add the ages. Now after that you will create one list array, this one, and you will fill initially it's to maximum value. Okay, now you will create one linked list queue. Okay, using linked list, and your dist of SRC will be 0, means this one. Initially it was 0, right? Now you will add this SRC into the queue, and now till while condition, okay, until the queue is not empty, you will, what you will do, you will take the element from queue, you will traverse its neighbor, okay, and you will check if the current distance of the neighbor node is greater than the distance of the node, means it's a parent node, okay, and plus 1. So you will assign it to distance of parent node plus 1, right? And then you will add that neighbor node into the queue, and then at the end you will return this dist array. So yeah, that's it. Thank you.